Okay, so for today's class, we're still looking at standard 8 NS1, but we're going to talk about some square roots and cube roots today. We've already mentioned what square roots are. We've gone in depth with square roots and just about solving equations. And we talk about in order to get rid of a square root or the inverse of a square root is square, right? Now we're going to talk about cube root, and it's basically the same. I'd love to hear your input as to what you think the inverse of a cube root is. If the inverse of a square root is square, what's the inverse of a cube root? Recording. All right, so I'm going to go back and just refresh a little bit. So the square root of 2 is the same thing as 2 to the half power. I don't know if you remember that, but that's the same thing as 2 to the half power. Now, if I want to get rid of the square root, in order to do that, if we remember, I need to square it, right? Which would give me, because those would cancel out, so my answer would be 2. It's the same thing as if I had 2 to the half power, and in order to get rid of that half, I would square it. And then obviously you multiply those two, so 2 times a half is 1, so I would get 2 to the 1, which is 2. Same thing as that. So the square, the inverse of the square is a square root and vice versa. Technically this right here, there's a small little 2 in there, but we don't write that, all right? However, when we get to the cube root, we need to write that. So for example, if I say the cube root of 3, and I need to get rid of this cube root, in order to do that, I cube it. So this is 3 because this cancels that. I need to put that little 3 in there that you see right there. This is the same thing as 3 to the 1/3, right? And in order to get rid of that 1/3, I cube it. So it's 3 to the first power, which is 3. So if I have a cube root, in order to get rid of the cube root, I cube it. In order to get rid of a cube, I cube root it. So if you look in your calculator, you realize that there is actually a cube root function button that's on there. I think you have to press shift and then you'll click it. But it's honestly the same stuff, just like square root. It's just that we're talking about a different root. I'm not talking about a square root anymore. We're talking about a different root. So if we're going to solve equations, normally if we had, say for instance, we had the square root of x is equal to 4. And I want to find what, x is, I would square it, right? And whatever you do to one side, you do to the next side. So x, so since these cancel out, x is equal to 16, because 4 times 4 is 16. If I give an example saying the cube root of 2 is equal, let's do cube root of x is equal to 2, right? In order to get rid of this, I need to cube it. And whatever you do to one side, got to do to the other side. So x is equal to 8. 2 cubed is 8 because 2 cubed is saying 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. So then my answer is 8. I'm going to put it right down here in this little box. If I had the cube root of x plus 1, say the cube root is over x plus 1 is equal to 1. And I need to solve it, okay? In order to get rid of a cube root, I need to cube it. Whatever you do to one side, do it to the next side. So then I'm left with x plus 1 is equal to 1 cubed is 1. And then I go through, I do the additive inverse. So x is equal to 0. So again, I'm just introducing the cube root, all right? It's just similar to the square root in terms of the inverses. So the square root inverse is square, and the cube root inverse is cube. And whatever you do to one side, you do to the next side, obviously. And then you go through and you solve like you would regular equations, whether that's distributive property, combining like terms, additive inverse, multiplicative inverse. I'm just introducing the cube root.